Okay, we're talking about section 2 today. Section 2 of chapter 5, Let Us Entertain You, Making Waves. Really like this section because of the amount of material it has in it that students have to know, that students will be using for their assessment. So very important section. Let's go through it. Now it's pretty simple as far as materials. Basically, you need slinkies. All right, and if you don't have the slinkies that came with the active physics kits, which tend to be a little bit longer, larger, that's okay. You could pick up a slinky from a toy store. They're pretty cheap. Toys R Us, Walmart, whatever is close to you, and get a couple for your classroom. Now, the book does give a little warning about students being careful with these things and them getting tangled up, and that's no joke, okay? So ninth graders tend to get very excited for some reason with using slinkies. I don't know if it brings them back to their childhood, but if students are whipping these around or if they're stretching them out and then letting go, they will get tangled and they're almost impossible to get untangled. So please monitor the use of this with students, model how to use it, and make sure you're going around the classroom, making sure students are using them safely and appropriately. Now, a good way to model this lesson, actually, if you go to this website, gpb.org, the Georgia Public Broadcasting website, has a really nice lesson on the introduction to waves that I like to use in my class. If anything, just to show them how to use the slinky appropriately. Okay, so typically this lesson will take you about 2 days if you just go through each activity and each question. For me, it takes over a week because I use a lot of supplementary materials, and I'll talk about those. Here's one of them. This video has some note-taking guides students could use. You could print this out, give to students as you go through the video. It has an optional pendulum lab you could do with students. So a lot of good stuff here, a lot of reinforcement, especially since this chapter introduces a lot of terms and concepts, and we'll talk about that in a minute. But I just want to show you around 14 minutes, they actually have the students doing a lab like the kids will be doing in your class. So this is good to show students, if anything, just this little part, so you can get a feel for how they're going to be conducting the lab, okay? So again, a good resource there that you could show students, if anything, just one part, but the entire video is pretty good, and you might want to supplement some of your instruction with that. And getting back to the fact that there's quite a bit introduced in this chapter, one thing I like to do at the end of the activity is make sure I get this concrete in their notebooks for the students. I like to show some slides of a wave diagram, have them label it, have them define these terms, what they mean, and then show some slides at the end where we discuss differences in amplitude between waves, differences in wavelength between waves, shorter and longer, and differences in frequency. A lot of terms that you need to make sure students are understanding, and visuals will help tremendously with that. So definitely want to get some slides up there for students to look at. You can find a lot of good images on Google to use in your slides. So just something you want to think about. Now, as they progress through the lab, eventually they're going to be asked to change or use a slinky of a different tension and see how that affects the speed. This is an important concept they need to know as part of the standards, what affects the speed of a wave. And indeed, it is the medium or the material of the wave, the properties of that medium. So this site, again, actually demonstrates how students can use the same slinky and just increase the tension by stretching it differently. So if you look at this Georgia Public Broadcasting site, and if we go to a part, I think about 22 minutes or so into the video, all right, it will actually demonstrate how you can make the slinky more tense, more tension.
What does?
And then how students will use that for the next part of the lab. So it's a good thing to show, just to demonstrate.
But stretched
tighter. Of course, you could demonstrate this yourself to your students, but you need to show students how to do this.
Time the pulse traveling in a tighter spring. This time it takes 1.6 seconds for the pulse.
All right, so that's another good thing to show students if you're not using the whole video, at least that part, to guide them through that part of the lab where they need to increase the tension in the spring to see how that affects speed. All right, eventually as they continue on, they're going to be asked to make stand-in waves, and this is very new to students. They may not be familiar with that. So there's a good video on YouTube. St. Mary's High School Physics put a very short clip, and it shows different stand-in waves. It'll go through the differences in wavelengths of these standing waves. You can see that pop up here. So this is a good video to show as a reference to students so they know what they're looking for when they make this. Now, as you go through this yourself with the students, you're probably going to find they're going to have difficulty getting accurate measurements as they put a meter stick down and measure the waves they make, and as well as counting the frequency. That's always very tricky for students. So I often like to supplement this by the PhET activity, Waves on the String. I introduced this resource before, and you could take a whole day and get one of these activities teacher put up if you have access to Computer Lab and have students go through it themselves, or you could just show it as a demo. And it's much easier to get accurate measurements when you can pause time and you can measure. And so the computer makes this a little bit easier for students to measure and talk about the frequency. You have actual values here. So just something to consider, something you might want to show or actually do with your students if you have access to those computers. As they continue, it's going to introduce the concept of a transverse versus longitudinal wave, which is in standards, something very important. I always like to show a brief video on that. YouTube has like a very brief 6-second video, but it brings home the point and the difference of vibrations between transverse and longitudinal. So something you may want to consider showing the students, and then demonstrate with the Slinky how to make a longitudinal wave before they actually go forward and do that. They tend to need a demonstration of that. Now, the textbook links the longitudinal waves to a sound wave, which of course is very important. That's in the standards and something that students will be tested on. So I have a great site I like to use as well to bring that home. If you pause and copy this down, then check out this website here. I'll show you it right now. This site actually shows, well, I don't have it available right now, but it actually shows the particles vibrating, okay, and how they vibrate differently for a transverse and longitudinal wave. I'll see if I can pull this up real quick and show you that. So you can see, I like to have students stare at the particle and how they're vibrating and actually ask them if it's traveling. And they'll notice if they look at that red dot or any of the dots, they just vibrate. So you could reinforce that waves transfer energy, not the matter. Another important concept they need to know. And if you have a speaker available to show students how it vibrates longitudinally, that's always good. Or you could go back to PhET and show the PhET, or even YouTube and show how a speaker vibrates to reinforce sound as a longitudinal wave, something students need to know. Now at the end, you're going to get to this formula in that chapter, and very important thing students need to know. I like to show the formula, what each means, the units, and formula triangle. For my students who aren't so strong in the algebra, how can they change the formula to solve for frequency or wavelength, depending on what they're asked? So you may want to consider showing how to use the formula triangle. But definitely, you're going to need a lot of practice with this with your students. I know you're probably going to have to do what we like to call some drill and kill. I know, science would like to have the hands-on and get them going, but you need to take a day, 2, 3 days, depending on your students, practicing how to use this. You can find a lot of practice problems online. You can make your own, or you could go on the Weebly to the MCAS site and pull out some problems from the previous MCAS. But you're going to have to really practice with this. There's going to be problems they're going to encounter on the MCAS, and they really need to know what this formula means and the relationship that's shown here, and how to use this, how to solve these problems. So you want to take the time to do this. The textbook doesn't have a lot of example problems, so you're going to have to supplement. But the good news is there's a lot of stuff available out there that's easy to find. So that's what I do for this lesson. I find it to be probably the most important lesson in this entire chapter. So thank you.